A very warm good morning to all of you. Today we are going to start our first chapter of this chemistry, that is solid state. And might be you people are thinking that what are there to study? Solid state. We are so familiar with this word since class 6, 7. We are doing that. They are the matter are of three states: solid, liquid, and gas. But here, in being in class 12th, we will know little detail in the solid form, solid state, that we will go inside the solid, and then we will learn the things. Okay, so let me start. And solid state, let me start with the definition first. Solid is that phase of matter which has rigidity and have a definite shape along with the definite volume. That means it will why it is rigidity, because intermolecular force of attraction will be quite high, and that's why it will be rigid, and will have the definite shape, definite volume, that we all know since class 6, 7. Yes. Now, next thing, substance exists as solid due to high intermolecular force of attraction and high thermal stability. Why the substance will exist as a solid or liquid or gas? So, see, if the particle intermolecular force of attraction is quite high, the atom of that molecule are quite closer to each other, compact to each other, and that's why they form solid. Yes. And since the force of attraction is quite high, so obviously it is not going to break on little heating as the gas and the what liquid can do. Yes. So that's why they have the highest thermal stability too. Now, crystalline and amorphous solids. So these two things we are going to discuss throughout this solid state. Okay. So before starting this, I just want to give you one example. Like you people have seen the windshield of the car. Yes. And the glass, the window pane also, glass window also. So okay, if something by mistake, or like you people have met an accident, or maybe you people have seen that accident, car accident. So in that, you have seen that the windshield gets crushed, completely crushed, and it gives a sugar like crystal, isn't it? छोटे छोटे बहुत ही sugar like crystal it gives. All crystals are almost same size, shape, and all this thing. But if by mistake or किसी भी तरीके से if अगर घर का विंडो टूट गया, ग्लास विंडो टूट गया, या ग्लास वेयर या ग्लास बॉटल टूट गई, या समथिंग प्लेट टूट गई, so you people have observed that it is giving you different shape, isn't it? Some is hexagon, some is trigon, some is we can say parallelogram. The different shape it is giving. So actually this is due to their nature. The one is called crystalline, that window shield, and another is called amorphous, the glass window, or the glass a plate we are using at home. Okay. Based on nature of order of constituent particles, solids are of two types. How we will arrange them, how we will classify them into two different parts. One is crystalline and amorphous, based on the order of constituent particles. That means how the constituent particles are arranged. Is this arrangement is for long range? Is it regular throughout that substance, or it is somewhere it is there and somewhere it is not there? So on that basis, it is of two types. So first is, let's start with the crystalline solid. Crystalline solid, that means if let me show complete. Crystalline solid, in these solid the constituent particles are arranged in 3D, in definite geometry pattern 3D, which is known as long range. That means if you'll see that there will be a fixed pattern. Got it? Like you can see in this way, all that orange one, next all one is peach, next all is orange, next peach, like this. So there is a definite pattern, so that is called long range order. But and the example is quartz. This is the example quartz, that is which we use in toughened glass, which we use in what we say glass sorry, I mean to say windshield of the car and all. These have sharp melting point and anisotropic in nature. Sharp melting point, why they will have sharp melting point? As all the bonds are same, bond length are same, isn't it? All the bond length are same. So it needs same energy to break the bond. So at a particular temperature, might be 30 degree, 40 degree, or 100 degree, or 300 degree, whatever. As it will reach to that temperature, all the bonds will start breaking automatically. सारे के सारे bond जो होंगे वो break हो जाएंगे, isn't it? And that's why they have a sharp melting point. Exact point होता है, that either you can say that If we are talking about the metal, maybe it can melt on 50 degree or 90 degree or 1200 degree, something like that. So they have a sharp melting point. Okay, what is this anisotropic nature? Anisotropic nature is here to learn that might be asked as a definition, so that thing you have to learn. So here you can see in amorphous solid, you can see that there is no fixed pattern. Somewhere you can see that only green, green, green. Somewhere you can see only blue, blue, blue. Yes, so there is no fixed pattern. Someone is straight line in straight line, and here somewhere it is curved. So there is no fixed pattern. Got it? So that's why this type of things is called amorphous solid. Okay. So anisotropic nature. Let me explain about the anisotropic nature. Before that, just look at this GIF. You can see that all is in the same shape, isn't it? You can see there is a long range wherever you're like you can see till wherever you can see it is in the same pattern, so that is called long range. Okay, now anisotropic nature is the properties of the substance, the characteristics of that substance, due to which the physical properties like refractive index, electrical resistance and conductivity, they will have the different values when they are measured along the different direction. ये point बहुत important है, you should learn this. Okay, मतलब if we will measure through different direction, it will give you the same, it will give you the different values. Why so? There is a long range, there is a pattern, then why it happens like that? So let me show you with an example. Suppose that I am making that this is the things, okay? Or you can say in that slide I can show you, no need to make it again. Here you can see, if you go along with this, what you will get? Only the orange, 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 isn't it? So according to that, you will get the properties, the value you will get. If you go along with this particle, suppose that orange one is A and peach one is B. So if you go along A particle, you will get the different values. कुछ वैल्यू होगी इसकी, रिफ्रैक्टिव इंडेक्स की वैल्यू होगी, इसकी इलेक्ट्रिकल रेजिस्टेंस कुछ होगी. If you go with this angle, you will only get the peach one. So that means obviously it is different. If you go in this way, there is a different pattern. One orange, one peach, one orange, one peach. If you go in this angle, through this angle, you will see that one orange, two peach, one orange, two peach, one orange, like this. So through the different angle, you are getting the different pattern. Okay, and that's why the values will be different. That all that refractive index, electrical resistance, conductivity, they will have the different values. Students get confused in this, and please don't it's a simple definition, but they get confused. So read one or two times at least, it will be clear. Okay, now if I'm talking about like next thing, it occurs due to the different arrangement of the particles along the different direction. As I told you, right now I have shown. Yes. Now, if we move to amorphous solid are that the particles, there is no fixed range, there is no, it is short range. Okay. In these solid, the constituent particles are not arranged in a regular pattern. और अगर regularity है भी, तो that is for short time, and that's why short range. That's why they are also amorphous solid are also known as short range solid. Okay, example quartz glass, which we use in like daily use, हमारे घर पे use होते हैं, window में use होते हैं, and all that. Okay, these substances have diffused melting point. Why it is so diffused melting point? Because there is no regular pattern, there is the bond length is not same. So somewhere it will like a smaller bond length is there, so it will get more energy, it needs more energy. Somewhere it is long bond length, so it will get less energy and it will start melting. Yes, so the same thing, due to this they get a range of temperature. For melting, they need a range of, they melt over a range of temperature. Hope it is clear. Yes, so why? Because they have not a fixed pattern, they don't have regular arrangement, that's why. And if we talk about the nature, this will be isotropic in nature. These undergo an irregular cleavage. What is this irregular cleavage? First let me explain this irregular cleavage ka matlab, like in this slide you can see this one. Yeah. If you will cut this this substance through this, you will get a clear cleavage you will get on both side, orange you will get, isn't it? Like if you are getting this way cleavage, if you are cutting it, you will get the same pattern, one orange half with then do two peach like this. Are you getting it? So it will give you the same cleavage, sharp cleavage. But if I'm going to tell you to cut this, if you cut this, what is this? You are getting blue only. If you are getting this in this way, you are getting only green one. So like different cleavage will be there. So it won't give you the regular cleavage. It will be irregular cleavage will be there. It's not sharp. Okay. Now the isotropic nature, it's opposite of anisotropic. Matlab in anisotropic, when we were measuring the physical properties through different angle, we were getting the different values. But in this case, we will get the same values. Wherever the angle we move, whatever the angle we change, we will get the same value. So why so? Because of, again, because of irregular pattern. There is no pattern. So wherever we go, it will be almost same. So same value there because it is mixture. There is no fixed pattern. So कहीं ब्लू ज्यादा है, कहीं रेड कम है, कहीं रेड ज्यादा है, ब्लू कम है. सो ऑन दिस, ऑन एन एवरेज इफ यू टेक मेन, so it will give you the fixed value. So that's why it is called isotropic in nature. Hope it is clear. Yes, let's move to next isotropic nature. I have written over here. It means due to the random arrangement of particles throughout the values of physical throughout the values of physical properties such as refractive index, electrical and thermal conductivity, etc., will have the same value in all direction as right now I have explained, and it is opposite to an isotropic nature. In the isotropic nature, it will give you the same value from all direction, and in anisotropic, it will give you the different values from different angle. Anisotropic, crystalline are anisotropic, while amorphous are isotropic. Okay, this is the note you are supposed to learn, and you can say as a difference of crystalline and amorphous solid. Crystalline solids gives a clean cleavage. अभी बताया मैंने, yes, while amorphous will give you a irregular cleavage. This can work as a difference between crystalline and amorphous solid. Due to the above reason, crystalline solids are the true solid. They are called true solid, while amorphous will be considered as pseudo solid. Why so? Amorphous solids are considered as true. It is repeating over here. So let me cut it. Okay. Whereas amorphous solids are considered to be highly supercooled liquid of very high viscosity. That glass, you might be wondering first time you are getting you are listening this, that glass is a liquid. Yes, but actually you can't say simply liquid. It is a super cooled liquid. Liquid को बहुत ही ये पे ठंडा किया हुआ, super cooled liquid, and which is having very high viscosity. That means the flowing tendency is least. Got it? This is the reason that in the ancient building, the question can be asked that in the ancient building, the window pane, the bottom of the window pane becomes thicker. Why? Thick हो जाते हैं क्यों? So this is the reason actually. क्या होता है कि जो बहुत सालों से टिके हुए, बहुत सैकड़ों सालों से टिके हुए हैं, जो windows glass उस पर टिके हुए हैं, it happens for them only, not in our house, जो कि हमारा daily हर 2 years 3 years पे maybe कहीं कुछ ना कुछ करके वो change होता रहता है. So it's not like that. Okay. Chali. So let me explain the thing. What happens in that case? Because it is a super cooled liquid. So as temperature increases in the daytime, it get the energy and start melting. Got it? It start melting. So melt hona start with, but this flow जो है, the melting is so slow, very very slow. Got it? But as it comes at night time, that means जहाँ temperature down होता है, it stops. Again in the next day morning, again the temperature is there, it starts melting. In the night, the temperature is down, so again it stops. Same the process. It is occurring since long years. Okay, so that's why it is this. एक second, let me. This process is called annealing. Annealing का मतलब repeating heating and cooling of the substance. That is called annealing. I have written spelling correct. Yes, annealing. Got it? This is A. So repeated heating and cooling of the substance, that is called annealing. So students may be they may write this because of annealing of the annealing, they become pseudo solid, they become what we say, they are called pseudo solid. So you are supposed they become thicker at the bottom of the window pane, you can say like this. So but better hoga if you'll explain all this way, that amorphous solids are considered to be highly supercooled liquid of very high viscosity. So due to constant heating and cooling, in the bracket you can write annealing, the it starts melting in the daytime and stops in the night time. So at last, in the since like in many years, it becomes thick at the bottom. Got it? And since it is a like, we can see that it is a solid, but experimentally it is said that it is not a solid, it is super cool liquid. So that's why the glass is called pseudo solid. Okay. Now uses of amorphous solid, where we use, बहुत जगह use करते हैं, हर जगह. इन इनऑर्गेनिक ग्लासेस, दे आर द इनऑर्गेनिक ग्लासेस, ठीक है, जहां हम लेबोरेटरी में यूज करते हैं, इन द बीकर, इन द टेस्ट ट्यूब, फनल, नाउ तो एवरीथिंग इज आर ग्लास. यस, ग्लासवेयर, दैट मीन्स जो घर में हम यूटेंसिल्स यूज करते हैं, ग्लासवेयर, दैट इज कॉल्ड ग्लासवेयर. हाउसवेयर का मतलब लाइक विंडो में हम लगाते हैं, विंडो ग्लास, विंडो ग्लास डोर, समथिंग वी आर मेकिंग, सो दिस इज कॉल्ड हाउसवेयर. ओके. It is used as a photovoltaic material. What does it mean? Photovoltaic material. It is important. Photovoltaic material, as the name suggests, due to the light, if it generates electricity, or if it generates potential difference, matlab electricity, isn't it? So that type of material is called photovoltaic material. Okay. And one of the best example is silicon, that we will do it in last also, in the last of this topic, the chapter also. So silicon is the best photovoltaic material, and this is amorphous silicon, actually is one of the best photovoltaic material, which is used for conversion of sunlight into electricity, and that's why it is used for used in solar panel. The silicon is used, amorphous silicon is used. Okay. It is also used in form of large number of plastics. We can see that bucket and mugs and some plastic things are there, which when we break, it gives a different shape. Yes, बहुत brittle होते हैं, बहुत आसानी से टूट जाते हैं, and they give different shape. So that is also due to this amorphous solid. Okay. In rubber, used as making tires, shoes, soles, etc. रबर में भी हम यूज करते हैं, जहां हम टायर्स बनाते हैं, शूज बनाते हैं, सोल्स बनाते हैं, like that. This is an example, like you can see that crystalline. This is the crystalline, that is a fixed pattern all over. Polycrystalline, if the fixed pattern is there, but in the small group, if it is like that, there's a fixed pattern, there's a fixed pattern, but in the small group, it is not in the, in this case, it is throughout the substance. In this case, it will be in the regular pattern, but for a small packet form. Amorphous, there is no regular pattern. You can see there, here it is triangle, here you can say that it is in form of pentagon. Yes, here it is, you can see that in the rhombic form. Yes, isn't it like this? So these are the different types. Chale. Now classification of crystalline solid. We have described the solid, we have identified the solid in two parts, crystalline and amorphous. Now we are going to classify the crystalline solid based on nature of the constituent particles and the binding force present between them. Constituent particles का क्या nature है, और उनके बीच में और उनके बीच में what is the type of force of attraction is there. On this basis, it is again of 4 types, and let me show you the 4 types: constituent particles and the binding force present between them. Okay. Crystalline solids are of 4 types. First is ionic. What happened? Ionic solid. Second is, you can see that, covalent solid. Third is molecular solid. Fourth is metallic solid. So if you want to number it, you can number. This is the ionic solid, and then we will do the covalent solid, and then we'll do the molecular solid, and then metallic solid, or in any way we can do. Okay. So these are the 4 types of crystalline solid. If we go a little in detail, molecular solid is again of 3 types. That is polar, non-polar, and hydrogen bonding. Okay, hydrogen bonded crystalline solid. So let me explain one by one all the things. First, we will start with the ionic solid. As the name suggests, it is made up of ions, isn't it? Made up of ion, 3D arrangement of cation and anion will be there. And which type of force of attraction is there? Strong electrostatic force of attraction will be there. Like we know, might be you have heard this in class 10th and 11th on, that one sodium ion in its crystal is surrounded by 6 chloride ions. Yes, similarly, one chloride ion in its crystal is surrounded by 6 Na plus ion. So like this, and the force of attraction is electrostatic force of attraction, which is very much strong. Due to this strong electrostatic force of attraction, they have high melting and boiling point. Got it? Okay. They are hard. Force of attraction बहुत hard होता है, तो hard होते हैं and brittle होते हैं in nature. They are also electrical insulator. They are electrical insulator in the solid state. Due to absence of free, sorry, it's not free, it's free ions. Okay, free ions. Okay, so ionic solid conduct the electricity due to ions, and that too in the molten or aqueous state, not in the solid state, because solid state mein it is not having free ions. Got it? So in the aqueous or molten state, they conduct electricity due to free ions. You can see that the red one is positive and the green one is negative, how they are going to combine with others, and it's so fast GIF, I can't stop it. So you can see that how they are forming the ionic solid, how they are combining with each other and they are forming the solid. Now the molecular solid is of 3 types. I have explained the polar and then non-polar and then hydrogen bonded. So start with the non-polar molecular solid. As the name suggests, non-polar, that means there will no what we say electronegativity difference between the atoms, isn't it? So like H2 ho gaya, Cl2 we are taking. So made up of molecules or atoms by non-polar covalent bond. Non-polar covalent bond ka matlab there will be sharing of electron between two atoms having same electronegativity, almost same electronegativity. Got it? Usually in liquid or gaseous state होते हैं ये at room temperature, and they are insulator also because they don't have free electrons, free ions, कुछ नहीं होते हैं. See, electrical conductivity can be of 2 types, either due to the free ions or due to the free electrons. In the molecular solid, neither they have free electrons nor they have free ions, so that's why they are bad conductor or insulator. Example, we can say H2, Cl2, I2, etc. Okay. Now, here you can see that iodine is, this is iodine, two purple color ka hota, that's why the purple balls are there. You can see 2 atoms of iodine, one iodine and another iodine, like this. Okay, you can see this is the iodine solid. This is the carbon dioxide solid, which is also called as dry ice. Carbon dioxide, now you'll say that in between carbon and oxygen there is electronegativity difference, isn't it? Yes, but still the molecule, they are like they have electronegativity difference between these two, but the molecule as a whole is what? Non-polar, because the dipole moment is going to be 0. So that will also considered as non-polar covalent compound. Okay. Chale. Now the polar molecular solid. Polar molecular solid, that means where the covalent bond will be there, but in between two different atoms which are different in the electronegativity. So made up of molecules bonded with the polar covalent bond. Okay. Molecules are held together by dipole interaction. कौन सा इंटरेक्शन होगा ये याद रखना है आपको, डाइपोल इंटरेक्शन. दे आर सॉफ्ट इंसुलेटर, एंड इंसुलेटर के लिए मैंने बता रखा है आपको क्यों हो रहा. एंड दे हैव आल्सो हाई मेल्टिंग पॉइंट बट not not equal to ionic solid. Ionic solid में there is a electrostatic force of attraction, so that's why it is strong enough. Got it? But in this case it is dipole interaction, so it is also strong with respect to the van der Waals force of attraction and other forces, but lesser than or weaker than the electrostatic force of attraction. Hope it is clear. Example, you can see that HCl, SO2, CCl4 and H3, where the polar covalent bond is present between them. Okay, this is the picture. You can see that plus minus how they are going to combine, and they are arranged in a particular pattern, and that's why they form a solid. H bonded molecular solid, hydrogen bonded. So we know that hydrogen bond is formed between hydrogen of one molecule and FON of another molecule, isn't it? So, and after that all that 17th group element will be there, but they don't form the hydrogen bond with this. मोस्ट इलेक्ट्रोनेगेटिव, और वो भी सिर्फ 3, not with any other. Like it can be asked that why HCl is gas while HF is liquid. So HF can form the hydrogen bond, that's why it is in liquid state, but HCl cannot form hydrogen bond, that's why it is gas. Molecules are which type of bond will be there, obviously quite clear hai yahan pe ki the bond will be hydrogen bond. So since it is having hydrogen bonds, so obviously they will be in the liquid form, and liquid are volatile. But अगर इनको हम थोड़ा सा strong कर देते हैं तो if we combine compress it, तो it can form solid, but वो भी soft solid होंगे, that means easily convert हो जाएंगे liquid में. Example of this structure of ice. Here you can see that one water molecule. This is the one water molecule. That brown one is the oxygen, and two, this white are the oxygen. Hydrogen. Got it? So in class 11th chemical equilibrium, you might have heard this, that one water molecule is attached with the 4 water molecules. You can see one water molecule over here, another water molecule is here. This is the first water molecule, this is the second water molecule. You can say third is here, which is above the surface, and this is fourth below the surface. Got it? So it is like that. So one water molecule is surrounded by 4 water molecules in the ice, and that's why the ice structure, if we want to write the formula of ice, it shouldn't be H2O is the H2 is not the proper way. It is H9O5 form plus form में exist करता है. Got it? So you have done in equilibrium chapter this. Now if we talk about this molecular solid, let's do in recap that they are of 3 types: non-polar, polar, and hydrogen bonding. They all will be molecular solid, non-polar and polar both will be soft, except the hydrogen bond, they will be, because this bond is little strong. All will be insulator of electricity. They all will have very low melting point. If we talk about the force of attraction, I have explained that in the non-polar there will be dispersion force, and in their polar there will be dipole-dipole interaction, and in hydrogen bond, obviously hydrogen bond will be there. Example I have written over here. Okay, so this was about the molecular solid. Now the covalent and network solid. The video is going little lengthy, long, but I have to complete this, so let me do it. Okay, covalent का मतलब होगा there will be only covalent bond and it will form a network like structure. Got it? So made up of crystalline solid of non-metals like carbon, silicon, they can form, held together by covalent bond and also known as giant molecule, क्योंकि आपस में combine होके they form the network like structure. Okay, so that's why it becomes a giant molecule, which is very strong and directional in nature. You all know this, you have done in chemical bonding that covalent bond are directional in nature, while the ionic bond are non-directional. So since it is directional in nature, so that's why here we can say that network solid is also directional in nature. And strong क्योंकि बहुत सारे network होते हैं, बहुत सारे covalent bond हो जाते हैं, उसमें मिल जाते हैं, so that's why इनका melting point भी high हो जाता है. But still it is insulator because of neither free ions nor free electrons. Example, diamond, carborundum, the formula is SiC, and except graphite. Graphite is like all सारी चीजें सही हैं इसके लिए, but एक last वाला point जो कि ये insulator होते हैं, no, graphite is conductor. Okay, graphite conduct electricity. And why it's so? You have done in class 10th. See, in the graphite, actually, what happens? There is a one carbon in one plane. This is attached with the 2 different carbon like this. Okay, and in the next plane, this is in one plane. ये एक plane में होगा. In the next plane, this is attached with the double. ये दूसरे carbon से double bonded attached होता है. So whenever we subject it to some change, some heating and something like that, so what will happen? This bond get broken, and this bond is broken, and then it will form. This is, let me do. This will. Where is that? Okay, the bond will break on this side and on this side. It's not visible. This color is, so due to which there will be a single electron on both sides. That means a free electrons, isn't it? So free electrons, due to that it will conduct the electricity. Hope it is clear. Yes. So actually it is double layer, multi-layer. So वहाँ पे ये conduct करता है electricity को. In graphite, the 4th valence electron of each atom is present in between different layers which are free to move, due to which it is a good conductor of electricity, that I have explained right now only. Okay, and this is the structure. And this is the last type of solid, that is the metallic solid. Metallic solid are the solid which is having like metal bond. Okay, they will have metal bond. And in this, what is happening, the positive ion, the cation, is surrounded by not the anion, it is surrounded by the negative electrons, not anion. Here it is, metal is surrounded by electrons only. Okay, so due to this free electron, they conduct electricity, and have even in the solid state they can conduct electricity, because they have free electrons all the time. No need to be insoluble in water, ये अपने आप ही conduct कर सकते हैं. Okay, and they have high electrical and thermal conductivity, बहुत ज़्यादा high होती हैं. They are lustrous, all the metal properties we can say, lustrous, highly malleable and ductile. Which type of bond is present? Metallic bond, metal bond. You can see that metal bond is there. Yes, and these are the electrons arrangement over there. This is the recapitulation. Let's do quickly. Molecular solid, atom and molecule जो भी होंगे इनमें unit particles I have written. The force, the one thing which you have to remember is this: the types of bond present in the in between. Okay, and this is all the things which we have explained, which I have explained there. That is the same thing I have written over here. So just please go through with this, and I hope the basic thing of that solid state is clear now. So this was the basic thing, you know. In next class we will do further, we will move. So by the time, go through with the video properly, make short notes for that, and try to understand the things. If it is still not clear, please let me know, I will explain again. Okay, till then, thank you class.